Hello, this is Ben Zimmer from Enable Training and Consulting, bringing you the next installment of the LV Mastery Tip Jar. In this installment, we're going to talk about the Dashboard project from the point of view of the FRC FIRST Robotics Competition. This is the project which will allow us to use a computer at our driver station which communicates with the robot in competition. Let's begin by opening up the robot project which we created over the last few tip jar videos. Recall that what we've previously done is to create a sub-VI which contains a state machine to control a mechanical lifting assembly. We've added a debugging dashboard which allows us to internally debug but will not work during competition. And we've also added a simulated mode within our lifter sub-VI. So let's proceed now by talking about this VI. This is the Dashboard Data.vi. Let's open it up. On the block diagram of this VI, we see at its heart a while loop which runs forever until the program is manually terminated, and two shift registers, the top which is a numeric and the bottom which is a cluster. There's a little bit of documentation here which tells us that the top loop is actually a counter. The purpose of the counter is to keep track of how many times this loop has run. And the reason we want to do that is we want to perform different actions depending on what stage we are in running. It's described as saying to disperse work across 50 calls to keep overhead low. And the way that works is to use this function, which is the quotient and remainder VI. Essentially, it takes this number, divides by 50, and gives you out the remainder. So we know that the remainder will always be between 0 and 49. And so, using this case structure here, depending on the value of that remainder, different tasks will be performed based on the value of the counter. So we're going to modify this to contain our own custom information and to send that back to our dashboard application, which is going to be running back on the driver station computer. So we're going to need to make modifications to this case structure, and we're going to need to make modifications to the second shift register. This shift register contains the actual dashboard data. This is the data that's going to be sent from the robot to the dashboard program running on our driver station. It's a shift register, so we know that it keeps its value from loop to loop to loop. And what happens inside this case structure is different values are inserted into the shift register. So for example, if we were to take a look at the default case of this case structure, nothing happens. The input value coming from the shift register terminal is wired directly to the output value. Whereas if we're in steps 0 to 15, then depending on the value of some enable bits, certain information is added back in to that cluster. So we see here in steps 0 through 15, information is pulled out from the top value using this unbundle function, modified, voltage is read, inserted into an array, and then rebundled into the cluster. This code may look a little bit daunting, but the good news is we don't have to change it. In fact, we probably shouldn't. But what is important to know is that we observe that these Boolean values are actually coming from this control here. It's called the Dashboard Enables control. And this is where we tell this VI which inputs and outputs we want to send back to the computer running at our driver station. So 0 through 15 are reserved for analogs. 20 and 30 are reserved for digital inputs and outputs, as well as PWM values. 40 is reserved for the states of the solenoid values. And all of the other counter values will go to the default state, which does nothing. So before we go any further and before we modify this VI at all, let's take another look at this dashboard enables. If we double click on the terminal to bring it up in the front panel, we see here that it is a cluster which contains a bunch of Boolean values. And here is where we can turn on or off whether we want this information to be sent back to the dashboard project. If we return just for a very quick second while we're on this topic to the robot main VI, we see that although it's an input wired to the front panel, by default there is no wire connected to the dashboard enables. What that means is, unless we wire something here, this will use the default value as defined by the VI itself. So if we're going to leave the architecture alone, what we need to do whenever we need to change these enables from their default values is to be sure that we save these default values. And the way to do that is you right click on the edge of the control, Data Operations, make current values default, and then save. And if you do that, you'll ensure that these values will be remembered every time that the robot program runs. So now that we've talked about the default behavior of the dashboard, we don't need to do anything more unless you want to make changes and add custom data back to the dashboard application. And I think it's probably pretty likely that you will. If you want to debug the states of your state machines, you want to watch what's going on in your robot, if you have any other parameters that are being tracked that you want to be able to watch in the driver station. So let's return to the block diagram. Remember that dashboard data is being contained within our shift register here. And if we want to add custom information, we need to edit the data type of this dashboard data. So luckily, when we right-click on this indicator here, we see that it's a typedef. So if we open up our typedef, we see by default all the PWM, digital, analog, and solenoid values. If we want to add some custom information, we just need to bring it into this typedef. So let's add a couple important internal values from our mechanical lifter that we built in the previous videos. So let's go back to robot main, then to our lifter sub-VI, take a look at the block diagram, and remember that what we're outputting from this shift register is being put into the lifter typedef global. So all that information is being placed in the global specifically so that we can take a look at it back at our robot main in our debug dashboard. So if we want that same capability in our driver station dashboard, why not make some of that same data available inside our dashboard typedef? So if we open up our debug dashboard, show the block diagram, remember that we're taking these values and displaying them here. So all we need to do is go to the front panel, copy these controls, return to our dashboard data type, and paste them in. So now, by adding these controls here, we've changed the data type of the dashboard data type. So we apply changes, save and close this typedef, and go back to our build dashboard data. So we've done part of the task. We've added the extra data we want into the data type, but we haven't written it anywhere. So what we need to do is modify this code by adding a case where we're going to write that data into this shift register. So why don't we take a duplicate of our default case, which by default will take the first available undefined numeric value, which is 16. And in this case, we're going to say update the lifter data. So again, whatever we put in this code is only going to run when the counter value, when divided by 50, gives a remainder of 16. What we need to do in here is bundle by name and modify this bundle by name so that it accesses the parameters we want to write to. So the only thing left to do is actually get those parameters. Well, one of the reasons we created that global variable, which can be read anywhere but only written to in the lifter sub-VI, is so that we can read them in this kind of application. So let's return to the lifter state machine sub-VI, take a copy of our global, and paste it in here. Change it to read, and unbundle by name. So we're going to extract just those parameters that we want to put into the dashboard VI. And then we just need to connect these guys up. A natural question would be, why didn't we put this entire global variable into our dashboard? Well, that's certainly a possibility. You could do that, but you want to minimize the amount of data you put into this dashboard control, because that data is going to be sent from the robot to the program running at our driver station as often as possible. So you want to minimize the quantity of data. If it's not really required, for example, the device references for all the switches and motors are really not of any value back in the dashboard application. However, the values of the sensors and maybe the internal state of the lifter certainly are. So now, once we save and close our dashboard data and our lifter sub-VI and everything else, We've essentially made the modifications we need to put custom information into the dashboard data.